So let's have a little fun by comparing and contrasting Java I/O streams with some other technologies that you may be familiar with, Java technologies in particular. And we'll start out by comparing and contrasting Java streams with something with a very similar name but a slightly different behavior, or a very different behavior, which is I/O streams. So we'll talk about how to program with I/O streams and Java streams together, because that's actually a very useful thing to be able to do. So what is an I/O stream? It's an input source or an output destination. And this has been around since the beginning of time with Java. So Java 1 had a lot of these features in it. So you've got some kind of source, like a file, and you want to get the file into your program. You can use a stream, an I/O stream, to do that. And you can also take a program and use an I/O stream to write something to the data source. This is not the same as a Java stream. So you can read data from a source one chunk at a time, or one item at a time, and you can write data to a source, to a destination rather, one item at a time. An I/O stream is an abstraction of a physical or virtual storage media. So it could be a disk file, it could be a device like some kind of device driver or network. It could be other programs, it could be arrays that exist in memory, and so on and so forth. So you've got a whole bunch of things that you can use to read and write using your application with input streams and output streams. There's all kinds of different data with a stream. You can have chunks of bytes. You can have primitive data types like ints and longs and doubles. You can have things that are localized to be for US English or British English or other languages for that matter. And you can also read and write objects with the appropriate converters to take something that's more highly structured and turn it into something that can be stored or transmitted over a network efficiently. Some I/O streams just pass the data down to whatever the device is under the hood, whereas other I/O streams manipulate and transform the data in various ways. And in fact, if you take a look, this is a diagram that shows the inheritance relationships between various parts of the I/O streams hierarchy. And this actually applies something called the decorator pattern. So we won't spend much time on that, but that's a good old Gang of Four pattern from the good old Gang of Four book that you should be aware of, that existing. And if you ever need an example of a decorator, this is the one in Java. The key thing to note is that an I/O stream is not the same thing as a Java stream. So the I/O streams here are for getting data from or to data sources, whereas you can see that Java streams are for transforming data, which already exists in the memory of the computer, using various types of operations, either transforming or filtering and so on. And as we know, this is to do things in a declarative way. Of course, you can use these things together. So you can use this to get input from some source and then pipe it through a bunch of transforming operations or filtering operations, and then output it somewhere using streams. So I/O streams and Java streams can work together very nicely. And there's a bunch of really fun examples that we'll just talk about briefly here that show how nicely they work together. In fact, they've explicitly designed modern I/O streams to work together with Java streams. And here are some examples. So there's a utility class called files, and there's a lines method for files. And basically, that takes a file and it breaks it up into a stream of lines. Pretty cool. There's this thing called a buffered reader, where you can do buffered reading, and then you can take the results of buffered reading and play it out as a stream, also using a lines method. There's a method here called files read all lines, and you can basically use it to read a file into a list of string objects. That would work very nicely for the example we looked at with Shakespeare that we had, although I needed to do things a slightly different way. But basically, these are all ways of being able to process files using a combination of I/O streams and Java streams. And here's a simple example. This illustrates how to use a modern Java I/O stream capability and Java streams to build a cosine vector map from a comma-separated value file containing movie cosine values. Why the heck would you want to do this? If you were building a recommendation engine, you might have a file consisting of movies and encodings of information about the movies, like what's the genre, who are the actors, who's the director, what's the movie rating, PG, PG-13, R, and so on. And you could use this to build a recommendation engine. In fact, my class I teach in the spring does exactly that. And what we can do here is we can take that file, so we say files.lines, and that will go ahead and open the file and give us a stream of lines in the file. So now we have a file, we have a stream that contains the elements in that file. And we then skip over the first element because that's just telling us what the file contains. We split things based on a comma, or semicolon rather. So now we have lines split up into essentially 2 strings. And then we create a simple entry. We saw simple entry before, which is this key value pair entity with the name of the movie followed by the cosine vector. And we take the vector as a string and we turn it into essentially a list or an array of doubles. And then we collect everything to a map where we have the name of the movie and the cosine vector as the result. And this is just done if we have 2 movies with the same name, which we will not have, but you need to put it there for syntactic reasons. And this example, which is in the EX40 folder, shows how to do this. And it's really cool. It demonstrates how you can combine I/O streams with Java streams in order to do something that otherwise is a little bit tricky. And I wrote this code a couple of years ago, and I should amuse myself by going back now and seeing if I could regenerate something like this using ChatGPT. It probably could do it. It might be a little tricky. I wouldn't be surprised if it could do it. But just a fun example of how you can combine 2 things together. And you can get this in the EX40 project in my Java 8 folder in the Live Lessons GitHub repository. So that's the end of our discussion of combining Java streams and I/O streams.